Okay, we are back. And please bear with us for that small technical problem. So we have the what? Format. Value is equal to -1 exponent s. If s is 0, that means -1 to 0 is 1. Okay? So that's why if we see 0 on the first digit here, it means that the number is positive because -1 to the exponent 0 is equal to 1. Any number to the exponent 0 is equal to 1. That is positive. Okay? So that's why we have this formula times 1 times m. M is mantisa, and that is what? 32 minus 9. How many is this?
23, sir.
23. So 23. Mantisa is 23 digits. So here. Okay. So just follow the format. Just follow the format. We have to follow the format, otherwise the computer will not be able to recognize any word that will give us. So any word that will give us input to the computer, they will not understand. So they will not understand us. So in order, this is what the type of quiz or exam that we are dealing with in our maybe our first long quiz. No, that's why you have to know how to do it manually and how to do it with calculator. Okay, example 1. Okay, sign, the first digit is 1. Therefore, -1 to the exponent 1 is equal to -1. That is the reason why 1, it means negative. 0 means positive. Okay, so this here. -1 to the exponent 1 is -1. That's why the number is negative. Because of this. Okay, because of this, the given number is negative. So bias exponent, that is 8 digits. Okay, so the given is 101 00010. So convert this to decimal. Okay, convert this to decimal by what? Converting binary to decimal is easier because this is what? The first digit 2 to the first power is 0. Next one is 1. 2 to the second power is what? 2 to the first power. 2 to the 0 power, 2 to the 1 power, 2 to the 2 power, 2 to the 3 power, and so on. The exponent is from 0. So here, can you see my here, can you see this? That one.
Yes, sir.
Okay?
Yes, po, sir.
So that means 0. That is 2 to the 0 power. Okay? 2 to the 0 power is 0. Times 0 is equal to 0. But that's why we don't need to talk about that. We need only to talk about what? This one, and this one. There are 3. There are 3 important things here because there are 3 ones. Diba? So this one, okay, please take a look. Okay. That one. Okay. That is 2 to the 1. 2 to the 1 is equal to 1. 2 to the power 1 is equal to 1. Times 1, that is, sorry. 2 to the 1 is 2. Okay? 2 to the power 1 is 2. Times 1 is 2. Okay? So, sorry about that. Okay? Okay? And the next one, the third digit is 2 to the 2 power. Then, the next one is 2 to the third power, 2 to the fourth power, and the important thing is the 1 here. This is the what? 1, 2, 3, 4, 5. Fifth power. 2 to the fifth power is 32. Okay? 2 to the fifth power is 32 times 1, 32. Okay? So, kanina, 2. This is equivalent to 2. And this is equivalent to 32. So, 32 plus 2 is 34. But we have another 1 here. Okay? So, this is what? 2 to the 1, 2, 3, 4, 5, 6, 7. 2 to the 7th power. 2 to the 7th power is 120. 64. 120.
28. 128 po, sir.
128. Okay, 128. So that is the how to do it. So you have to add 128 plus 32 plus 2. So 34 plus 128, that is what? How much? 162?
162 lahat, sir.
162. 162. That's why, if you can take a look here, E prime, take a look here, E prime, 162. Okay? That is how you do it manually. I can do it manually faster than using calculator. So 162. Okay? Here, you can see the 162 here. 162. That is what? The biased exponent E prime. Okay? So you can see this 162. And then minus 127. Why 100 by why it is 127? Because that is the formula here. The formula here is 127. Okay? So 162 minus 127, that is 35. Okay? 35. So 2 to the 35, please use your calculator. Now, I cannot do it manually. Faster. Use your calculator. Okay. So I can show you my calculator. Okay. So 2. I will do it. 2 to the exponent here. 35. So put 35 here. 35. I hope you are following my calculator. Okay, equals. That is, how much that? 3.43.
43.55.
3.43597. 3837 times 10. And multiply, that is the value of 2 to the 35. But we have to multiply it by what? By the mantisa. The mantisa is equal to
1.6.
1.625. Okay. Times 1.625 equals 5.583457485. Please write it down. Please write it down. 5.583457485. Okay. I will go back to our okay. So that is the right answer. 5.5834. Okay? Times 10 to the 10. The same. So after computing manually and finding out the sign, which is negative here, you just have to put the negative sign here. Because this value times negative 1 is negative 5.5834 times 10 to the 10 power. Okay? So this is how we do it. This is an example. Take note of this because this is similar to what will happen in our quiz and questions. Example number 2. Represent negative 5.5834 times 10 to the 10 as a single precision floating point number. Okay. So what is the formula here? No? The format. So, okay. We will return back. We will return back to binary. We will return back to binary. How to do it? We already know how to do it from the previous video and from my example. No? The decimal component, multiply by 2, multiply by 2, multiply by 2. The integer component, divide by 2, divide by 2, divide by 2, and so on. Okay? I already showed that. I don't need to repeat it over and over again. Okay? So that's how we can do it here. So the sign, -1, is just like this. This is the format. Times 1, point mantisa. This is mantisa. The question mark here is the mantisa. We need to calculate the mantisa using either manual or using your calculator. But since this is what? Decimal portion, I have yet to be able to get a calculator that can do that. Okay. Our calculator cannot do that as of now. So you need to do it manually. By what? Multiplying by 2. Continuously. Okay. Repeatedly multiply by 2. How about the question mark here? That is the exponent. Okay, that exponent has something to do with this biased exponent. So let us take a look. According to IIEE 745, that is the standard for what representation. 8 bits would represent what? This one. This is equal to 8 bits. From 0 to 255. Okay? Okay? Because 2 to the 8 is 256. 2 to the 8 is 256. Okay? So that's why from 0 to 255. Okay? You can confirm that. Please confirm 2 to the 8 is equal to 256. Okay?
Yes, sir.
Is that correct?
Yes po, sir.
Yes, sir.
Meaning to say, you have a good calculator. Your calculator probably is made in Japan. Not made in, you know what?
China.
Bias is 127. So, subtract 127 from this representation. Okay? So, we have this bias, meaning E prime. E prime. Yan yung bias exponent natin. So, exponent for special cases, actual range of E prime is from 1 to 254. Okay? So, E prime is equal to 0 and E prime is equal to 255 are reserved for special numbers. That is the maximum and minimum. So, that is the maximum minimum from 0 to 255. So, less than that, that is reserved for special. That's why we are only dealing with 1 to 254. Okay? Out of the total of 256. Out of the total 256, minus 2, 254. Because there are two numbers that are reserved for special numbers. That is 0 and 255. Actual range of E. So, 256 or 254 divided by 2. If you divide it by 2, that is 127. Okay? 254 divided 2. In your calculator, 127. Okay? That is an actual range of E. So, we have to start less than that. So, negative 126 up to 127. Okay? Special exponents and numbers continued. So, E prime is equal to 0 all zeros. E prime is equal to 255, all 1. If you confirm that in your calculator, that will give you the same answer. Okay? 255 meaning there are 7, 1. Okay? There are 7, 1. Put into your calculator under the binary 7, 1. Then convert it to decimal. It will become 255. Okay? You can do it. You can do it using your calculator. So, let us review. S is the sign. E prime is the biased exponent. M is the mantissa. And it represents this whole range of numbers. Okay? Okay. Okay. So, this is the tabulated information sheet. What's next? The same document, IIEE 754. What is the format of the definition and the formula? The largest number by magnitude. Out of that is what? All 1 and 2 raised to the 127 because maximum is 127. So that is the largest number. So if you convert this, you can use your calculator. That is equal to 3.40 something something times 10 to the exponent 38. Okay? You can immediately confirm this. I don't need to do it anymore. I will show you 1, 2, 3 times. Then you can do it on your own. The smallest number by magnitude. What is the smallest? Exponent is negative 126. 254 divided by 2 minus 1. That is negative 126. Okay? So, smallest meaning all zeros. Mantissa are all zeros. 1 point mantissa. So, 1.00000. So, there are so many zeros. Okay? So, if you convert that to decimal, that will give you the answer 2.18 times 10 to the negative 38. Okay? And because of that, we have what? Our machine epsilon. Machine epsilon is, we have the formula for machine epsilon. You can go back to the previous slide. Just follow the formula and you can compute this number, 1.19 times 10 to the negative 7. Okay? So these are the topics for the day. And thank you for listening. Okay? So please rewatch, review, and try example. Give random example to test your own self-study, and compare this into your lecture. Okay, if there are something that you forgot, so you have to come back to this lecture and take a look how to do it. So we already gave you how to do it step by step. Step by step. So do it by practicing more. Make any random number out of your head, then write it down, then try to convert decimal to binary back and forth. Decimal, binary, back and forth. And then try all of this definition. What are the definition here? Machine epsilon, absolute relative error, and so on. No? So there are several format, notation. So try to do it. Okay. So I do not need to give you any random number out of my head. You can do it on your own. Any number. Just like the example. The first example is what? 54.75. You can use any number that you like. Okay? So, anyway, we have to go to the next topic. before the time, again, let us remind everybody, we have to be serious about our study. Our purpose and our goal is to, for you, every one of you, to become an engineer. This is your professor, Dr. EYPEI, preaching engineering for nation building.